today's video we discuss about that what is the data structure and what is the types of the data structure and what is the terminology that used in the data structure. So first, what is the data structure? So data structure is a logical relationship existing between individual element of data and the logical or mathematical model of a particular organization of a data called data structure. That means when you create a model of its data, and that model we use in your problem, in your particular problem, programming problem, then we use that data structure. That in fourth point, that it is the specification of the element of the structure and the relation between them and the operation that may be performed on them. So that when we create that structure, when you can say that when we create that model, that with the help of that model we can easily perform our operation. So this is the basic aim of that data structures. So if we talk about that algorithm, so when we create our a data structure and then apply that any algorithm, so our program that be ready. So this is the basic concept behind that what is the data structure and algorithm, and how we create that our program. So next is that classification of the data structure. So data structure may be classified into two types, that primitive data structure and the non-primitive data structure. In primitive data structure, the integer, float, character, pointer, and the non-primitive data structure is that array, list, files. In list, linear list, non-linear list, linear list, the stacked queues and graph. So first we need to know that what is the primitive data structure. So these are the basic structure that and are directly operated upon by the machine instruction. Means that these are the fundamentals data structure that are known by the computer or machine. There is no need to define in that your program. So like integer that are defined by the all the number, so you don't need to again for the definition. So next is that non-primitive data structure. So in non-primitive data structure, like these are the derivative, they are derived from the primitive data structure. The non-primitive data structure implies emphasize on structuring of a group of homogeneous or heterogeneous data items. So this is the basic classification of the data structure, primitive and non-primitive. And next is that operation. What are the operation on the performing the data structure? So depend upon our problem, depend upon the situation, our operation. We use the following major six operation that we use in our data structure. First is traversing, searching, insertion, deletion, and sorting and merging. So what is the traversing? Traversing means accessing each record exactly once so that certain items in the record may be processed. Means you need to access each record exactly once time. Even the even your and if you even find that if you find that value, even you access all the items exactly once. In searching, finding the location of the record with a given key value. Means searching, you give a key value and that you matching all the item. If that match that item, you can stop. So means the difference is that traversing is always long process and searching is that you can maybe long or short, depend of that situation. Inserting means adding a new record or to the structure. It's very simple. And deleting, that removing a record from the structures. And sorting, arranging the record in some logical order. Means when your data given when you given your data, that maybe your data is not any logical order. So if you uh, create that in ascending order or descending order, so this is an example of the sorting. And when you two sorted file combine into single file, then the record is known as the merging. So this is the basic operation that perform in a data structure. Next is the important concept is the what is the abstract data type. For the understanding of the abstract data, before go for the abstract data, we know need to uh, uh, deeply definition for the data types and so the user. We need to know that what is your data type. So we know that define the two important things that about any data types. First is that define the certain domain of that values, and second is that define operation allowed on those values. Means like int type take only integer value that define domain of the value, and operation like addition, subtraction, multiplication, bitwise operation that perform in integer. So this is the uh, operation allowed on this operation. If we talk about the float, so float allows only addition, subtraction, multiplication, division. It's not allowed bitwise and percentage operation on that allowed. So this is the any data types contain these two things, domain and operation, that are defined by the machines and computer. But we talk about that user defined data types. So in this, the primitive data type, there is a concept of user defined types, and the operation and value of the user defined data types are not specified in the language itself, but is specified by the user. Means that uh, we the user define the domain and operation. What are the operation performed on that particular data types? Like structure, union are the example of the user defined data types. Like in structure, like we create any structure data types, then we use index int y. So we define a particular domain, particular uh, operation that what will perform. So this is the basic difference between user defined data types and the data types. Next we go for the abstract data types. So abstract data types are like user defined data types which define operation on value using function. There is a important point that uh, which defines operation on value using function without specifying what is there inside the function and how the operation are performed. So means abstract data type similarly is the data types user defined data types, but it use the function, and there is in abstract data type there is no need to worry about what is the inside the function. It is also good feature of that abstract data type, and the advantage of that we used why we use abstract data types. This is the answer of that question. So example like stack is the example of the abstract data types. So a stack consists of the element of the same type arranged in the sequential order. Like in that stack, whatever are the operation like push, pop, initialization, empty, push for the insert an element into the stack, pop, delete an element from the stack. So these are the operation, these are the function. We use that operation with the help of function. We create first function, then we use that data types as a function, and we need not to worry that what is the then side on the function. So next is the non-primitive linear data structure. The first is stacks that are saying about something in the abstract data types. Uh, so first need to know that what is a stack. So it is an ordered group of homogeneous items of element. Like when you put your shirt in your almaris, so you put one by one, one upon one shirts in one. So what is stack? It is an ordered group of homogeneous items of element. Elements are added to and removed from the top of the stack. So stack is follow that LIFO, like last in first out. So when you put in your all the sorts in your almaris, so you can arrange, you can put in the in one by one. But if you want to remove any sort like at the number of two. So what is a stack? So it is an order group of homogeneous items of element. Elements are added to and removed from the top of the stack. And the most recently added items are the top of the stack. Generally, stack follow the LIFO, last in, first out. There is some picture that are in the example of the stack. Like in your almari, you can put your sorts in one by one. So this is also example of the stack. So what's the operation that perform in the stack? Like push and pop. Push, the process of adding a new element to the top of the stack is called push operation. Like if you want to one more sort in your almaris, on the top. So there is a need to operation of the push. So if you want to add a new element in that your stack, so you need to push operation. Pop is the process of deleting an element from the top of the stack. It's called pop operation. Like if you want to remove the top of the sort, you can easily use the pop. But if you want to remove the number of the sort, so then we need to know, first to need to remove the fifth number of the sorts, then fourth number of sort, then third, and then the second. So this is the process. This is not directly, this is a manual process. You can directly remove in the quick data types. So some terminology that overflow, underflow. Overflow, this is a situation when stacks become full and no more element can be pushed on the stacks. And this point there is top, stack top is present and the highest location of the stack. Underflow, where when there is no element on the stack. Overflow is that when your almari is full of the sort, and even you want to add more sort, so there is a condition of the overflow. Underflow, there is no sort in your almari, so there is a condition of the underflow. Stack terminology like top. uh, the highest point of the stack is known as a top. When the top stores -1, that means there is no element, like underflow condition. And when when stack is full, that is condition of the overflow. Max size are the similarly the under overflow. And next is the array implementation of the stacks. The stacks can be implemented by the use of the array in English. So we can say that one data structure is can be implemented by the use of the another data structure. So one way to implement the stack is to have a data structure where a variable called top gives the location of the element in the stack. Sorry. So in that figure, you can understand what is the stack and what is the process of overflow and underflow. The first figure shows that there is a stack with the top 4 is item is 23 and the count 5, stack with the 5 element. And in second figure shows that the full stack, that there is a number of the count is equal to 6, count 6 stack size, and top equal to 5. And even 40 after that 43 also want to add that stack, but the stack is full. The stack maximum size equal to stack count maximum size equal to 6, so there is no space. So this is the condition of full stack. And in the third figure, there is no item in that stack, so this is an empty stack. In that condition, top equal to minus and count equal to 0. Push operation, in that first figure, that there is a stack with 5 element, that top equal to 4 and count equal to 5, that before push. But after element 15 element are want to push on that stack, so after push, the top equal to 5 and count equal to 6. So this is the push operation. This is push operation, and this is the next is the pop operation. In the first stack, there is a 5 element stack with 5 element, but in the second element, the 23 element are the delete from the stack. So after the deleting, we use pop. The top equal to 3 and count equal to 4, and before the pop, top equal to 4 and count equal to 5.